So we're in the midst of our pursuit in accomplishing the lab test, and I'd like to give a quick revision as well. So some of the things I'd like to cover is what is a OR logic. Let me enable my stylus. Go. So I'd like to introduce to you a OR logic. So an OR logic, like what it sounds like is it sounds like your OR gate. Remember in DE1 and your DE2, you have your OR gate, which looks something like that, right? So you have your two inputs here. So if you have a 0 and a 1, your output is still 1. If you have a 0 and a 0, your output is 0. Well, this is your 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 inputs, your two inputs, and this is your output, right? So 0 0, that gives you 0, 0 1, that's 1, 1 0, 1 1 1, that's 1. So why am I going through this? Well, in PLC there are many of times where we actually perform an OR logic but we don't notice. One example would be, suppose I have some condition here. Maybe I say in order for step 3 or step 1 to light up, I remember I mentioned that we needed a first scan. So maybe our first scan is one of the conditions, and then let's say step 2 kills it, right? So step 2, and then you can go to step 1 here, and then we say that, hey, if that's the case, then my step 1 will only turn on for that one scan cycle, right? It will turn on and it will turn off, so that's pointless. So okay, we say we need to latch it. So this is S1 again, right? So what happens now is that when my first scan is on for one scan cycle, it quickly turns on my S1. My S1 turns on, and then it causes this latch to become a NC latch, and then now current can flow in this path instead. It's an alternate path. So even though my FS is no longer present, but because it activated my S1 for one scan cycle, that was sufficient enough to activate S1's coil, and now we have an alternate path. So the alternate path would be, excuse me, the alternate path would look something like that. So it'll go from here, and then up, and then here. So that's how it will look like. That's the alternate path, right? So then remember we said that apart from just S1 and the first scan activating the initialized stage, which was our S1, we also mentioned that we also wanted to make sure it loops back, right? So our last step, which was S6, right after S6 is done, we go right back to S1, right? So we say we have another one here, and it says this is S6. So what have I done? Previously, before I drew the S6, I mentioned that S1 provided an alternate path, right? By doing another of the same type of so-called latch, we are creating a third alternative path, right? So now it's going through S6. So that means, for example, if I'm in S5, S1 won't light up. But the moment I'm in S6, S1 lights up. That means the moment S6 has taken place, or let's say it doesn't even need to be S6. For instance, maybe my F6 could be blink for 5 seconds. Then in that case, it wouldn't be S6, but it'll be like the 5 seconds, right? Maybe T on 1 dot Q or something like that, right? It's just another condition that provides an alternate path. So in this case, when we follow our truth table, this is known as the OR logic, because we are providing alternative paths. So how this works is either my first scan or my S1 or my S6 is on, that will trigger S1 to be on. That's why it's called OR logic. You realize it when you are actually saying it out loud like that, right? So why is this useful? Well, for instance, most of the time we have outputs like for example indicators. So let's say to indicate process is on or off, So the thing about PLC is we can only have one output, right? So for example, if I have one S1 here, that's the only one that's there. The one that we can have many of is the contacts. So for example, S1 here is our main output. You can have many contacts of S1. So you can think of S1 like a motor, right? You have one motor, and then once that motor activates, it has many coils that it can energize, right? So these are like the so-called S1 is the coil itself, and then it can energize many contacts. So these straight bars are the contacts that it can energize, right? So like I said, you can only have one output only, right? The moment you have two, it will conflict. Why? Because for instance, I say in step 3, one of my green LED is on, but then in step 4, my green LED is off. But then in step 3, I said that the green LED is to be on forever. So then what is the PLC supposed to do, right? If you want to implement this kind of conditions, we must do it onto only one output device. That means it'll be in like maybe one line, and then finally this is the output device, only one, right? Only one of it can exist. The moment you have two, your program's wrong, right? So this is why we use our logics, because for instance, like I said, only one S1 is there, but it activates at different conditions, right? So one of the conditions was FS, second was S1, third was S6. So you can adopt this method as well for your output devices, right? So the next one I like to go through is AND logic. So an AND logic, again, from DE, we learned that using an AND gate, this is our input and this is your output. The truth table will be 0, 0, 0, 0, 1, 0, 1, 0, 0, and then 1, 1, 1. So the output is only 1 when both of the inputs are 1, right? So this is the same. How it works in PLC would be that, for instance, your condition was sensor start and start button is on, then only you can go to S2, right? So it will look something like this. Oops. Let me change back. It looks something like this. You have one of the condition here, that's sensor start, right? And then the next condition was start push button, right? And only then you can go to S2, something like that. And then after that, oops. Yeah, only then you can go to S2. So for instance, my sensor start is activated, means I put the block at the sensor, but my start push button, I haven't pressed it yet, right? S2 will not light up. Similarly, if start button is pressed but then sensor start is not activated, then it won't start. That's the AND logic. Both of them must be on so that current can flow. Remember, current will flow from your vertical line here, right? Current flows here and then it goes here, right? So if one of them is normally open, then current can't flow and S2 won't be activated. Now that's the AND logic. So these are the two main logics that I like to go through with you and recap with you.